For our first problem, we have a funky function. There isn't a standard way to take the derivative of an absolute value function, and so you have to remember what the absolute value function looks like. If you think about the original absolute value function, the common function, or aka the parent function, it looks something like this. It's just straight up, right there, whatever you get on the positive side, you get on the negative side, because the absolute value bars make the negative numbers positive. So if you have a -3 inside there, what that does to our function, our graph, is that it shifts the graph over to the right 3, which is kind of weird, because if you think -3, you would think that you're supposed to go to the left, but you're not. Whenever something is happening to the x, this is a cheap rule, whenever something happening to the x inside of a group, then you think the opposite. So when it says -3, you think right 3. So this function shifted to the right 3. Alright, so that's that function, but what does this mean? This means, what is the slope at 1? At 1, what is the slope? So now if I'm looking at 1, we're looking at this point right here. What is the slope right there? Since this function is just up 1, right 1, up 1, right 1, or up 1, left 1, up 1, left 1, the slope right there at 1 is going to be -1. Yep, that's it. That's your answer for that one, -1. So mostly this question is about knowing how to graph that and knowing what this thing means right here, which is just simply asking you, what is the slope at 1? Oh, and there you have it, the definition of the derivative, the limit of a slope. That's what this is. This is the horizontal distance, the run, and this right here is your rise. This is a y value, and this is a y value. It doesn't show you what the function is, but you can figure it out. But pretty much this is basically asking, what is f prime at 10? Okay, so a equals 10. So the question is, what is f? I mean, that would be the cheap way to solve this, which I'm all for, really cheap, fast ways to solve things. But before I do that, let's just write down what the definition of a derivative is really quick. If you're trying to find a derivative at a, there's two definitions for this. You can take the limit as h approaches 0. H is your horizontal distance, that's your run. And then on the top, you're going to plug in two y values. You're going to plug in the y value when you plug in the a, whatever you get when you plug in the a. And then you're going to plug in the y value for when you plug in the other number that is not exactly a, but something different than a, to get two different y values. But because this limit is going to 0, both of these numbers are going to 0. But anyways, this is a definition of a derivative. Another way to write it is, let me do it backwards now. You take x and then you minus a. Remember, x1 minus x2, that's your run. Then on the top you have your x plugged in, and you have your a plugged in. This limit is as x approaches a. So this is still, the denominator is still going to 0, just like this one. But anyways, both of these are derivatives at a. They're both going to give you what the slope is at a. And so over here, since we have h approaching 0, unlike this one down here, we have x approaching 8. Up here, we have h approaching 0. We're going to use this template right here. So if you know that a equals 10, that the a right here that we've plugged into f is 10, and you know that this is just wanting the slope, if you find the function here, we can just use the power rule and solve it that way. And that's the cheap way of doing it, and that's the way I'm going to do it. So what is my function right here? If a is 10, I have 10 plus h. What is this? What is the function doing to 10 plus h? It looks like it's raising it to the third power. So that must mean that my function is x raised to the third power. Oh, that makes kind of sense, because if a were 10 and I were to plug the 10 into f, then I would get 10 raised to the third power, which would equal 1,000, which is what this other number is. Hey, that's what f of a is. F of a, when you plug in 10 to f, you get 1,000. All right, cool. So what is f prime now? F prime is 3 times 10 raised to the second power. No, not 10, you goofball. 3 times x raised to the second power. Okay, and then we plug in 10 to that. We get f prime of 10. 3 times 10 raised to the second power. And then we have 100 times 3, so we get 300. And that's your answer for that, dude. Bam. Boom shakalaka. Let's do this one since we're at it. We already have everything frozen and written out. It looks like A equals 8 in this case. F of x I haven't identified yet, but I have a very big clue. There's no h plugging into here. It's just an x, and if you just have to look at that. Okay, the square or the third root of x, and that makes sense because we could check it. Let's plug in 8. We get the third root of 8, and the third root of 8 equals 2. Hey, look at that. There's 2. Man, we are so awesome. Now let's do f prime. F prime of x, that means we're going to take the derivative of this guy right here. So I'm going to rewrite that as to the third power. Let's see. Let's rewrite this. X to the third power, or 1/3 power. And so we get 1/3 x, and then we have to take 1 away from the 1/3. That would be like subtracting 3 over 3, because that's what 1 is. Simplified, that would be 1/3 x raised to the negative 2 over 3. And let's write it even cleaner than that just for practice sake. We have x to the 2/3. That's the third root raised to the power of 2. All right, now I have to plug in my a, because since this is the definition of derivative, all that is looking for is f prime of 8. And so I just have to plug 8 into my x. I have 3, 8 raised to the 2 over 3. You could do the 3 first or the 2 first, meaning you can go 8 to the second power first, or you can go the third root of 8 first. And I'm going to do the third root of 8 because the third root of 8 is 2. And so I get 2 raised to the second power, and 2 raised to the second power is 4. 4 times 3 is 12. I get 1 over 12. All right, is my answer showing right here? Yeah, there he is. 1 over 12. Oh, dang, we got another one. Dang, another one. Oh, my goodness. Okay, so we got to look for the a. We got to look for the f of x. And then to confirm our f of x, let's plug in the a. Well, what is a first? So we can plug it in. Let's see here. It looks like this guy's the a right there. So I'm going to plug in pi over 3. And my function looks like it's just a cosine function. Let's check that out. Let's see. Cosine of pi over 3. Do I get 1/2? Let's see here. Oh, you know what? It's trig. You know, some of you guys are like, oh my gosh, it's trig. Okay, so let's see. We have this guy, and this guy in our unit circle. It's kind of not drawn the scale here. Okay, this would be that would be pi over 6. This guy would be pi over 3, and this guy would be pi over 4. We don't care about this guy and this guy. We want this guy. And so the coordinates for that one are, oh man, writing all sloppy here. Let's see, that would be 1/2, and then rad 3 over 2. And since cosine is the x value, you know, like if we were to draw a triangle, like so, whoops. This would be our cosine side, and this would be our sine side. Because this would be co-height, that would be height. And our co-height, since this side is the x value, we get 1/2. So cosine of pi over 3 is 1/2, which checks out. Check it out. Look at the 1/2. Oh my goodness. All right, so now what are we looking for? We're looking for f prime of pi over 3. So we need to find f prime. No problem. We get f prime of x equals negative sine x. And so we just got to plug in rad or pi over 3 to that. And oh, we already did that. Check it out. See, look, pi over 3 is rad 3 over 2, and it's negative out in front. So we get negative rad 3 over 2. We get our answer. Oh man, that was magical. Now for my favorites. I love when they give us tables. That means I don't have to take any derivatives of anything. Maybe am I wrong? Let's see. Let's start off with this one, number 5. It says h, capital H equals capital F of x squared. So what is h prime of 3? So there's two things we have to find here. We got to find h prime, and we got to plug in the 3 to it. let's find h prime first. Now check out, h is made up of two functions. We have a capital F and we have this squared. The squared is a function. It is doing something that's function. So we have to use a chain rule. We have the outside function, which is our squared, and we have the inside function, which is the capital F, and so we get down with it. We're going to have to drop that 2 in front of this capital F right here. Oops, goofy F. We're going to do that, and we're going to take 1 away, so we get a 1. We don't have to write the 1 exponent, but I'm writing it for your sake. And then we have to multiply this by the derivative of the inside function, says the chain rule. And then we're going to plug in 3. All right, so this is h prime right here. That's right, people. So now if I plug in 3, what does this look like? It looks like 2 times f of 3 times f prime of 3. And so I go here to my handy-dandy table, and I go, ooh, f of 3 is 5. So I put 5 in there. I get 2 times 5, and then I go f prime of 3, which is right here. We have f prime right there, so we have 4. It's 2 times 5, which is 10 times 4, which equals 40. Bam. Okay, let's look at the next one. This time, h is it's two functions dividing each other, which means quotient rule, derivative of the top first times the bottom. And then I'm going to have to take the top and multiply that times the derivative of the bottom. All right, and then we got gx raised to the second power on the bottom. We just got to make sure that on the top, because of this minus sign, that the bottom's derivative is second. It's after the minus sign. I mean, you could switch these two right here. You just can't switch this guy with this guy. Not okay. All right, so now I just got to plug in the 3. So I'm going to plug in the 3 right there, 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 plug in the 3 right there. Whoa, lots of plugins here. So we have f prime of 3, which we found earlier. F prime of 3, where are you? It's a 4. And we're multiplying 4 times g of 3. I'm looking, where's g of 3? G of 3 is right there, it's 2. So I plug in 2, and I go minus f prime of, no, just f of 3. I'm looking at that 3 like it's a power. It's just f of 3. F of 3 is 5, so I put 5 in right here. And then I have a g prime of 3. So I go g prime of 3, which is 7. Let's see here. I put a 7 right here, and then I go whoosh, and then I got to find g of 3, and then raise it to the second power. G of 3 is 2, raising that to the second power. All right, this is 8, 35, and then 4. 8 minus 35. Man, that's a funky 4. 8 of 27 over 8. No, that's not 8. It's 4. I divide that. Actually, let's not divide that. Hopefully, they just left it as an improper fraction. Yes, they did. Oh, my goodness. All right, so I got to do 7, 8, 9, and 10 with the same table. So check out the next vid.